welcome back to our YouTube channel GurMantra Seksha Ka Granth. I am your educator Nidhi Dua and I teach you chemistry at this platform. So basically guys, this is our GATE 2021 exam syllabus for chemistry that is compulsory for all Excel candidates. Section 1, which we have covered in the previous lectures, named atomic structure and periodicity. We have successfully completed this section. And we have started section 2, named structure and bonding. These are the topics which we have covered in the previous lectures. This is your section 1, while this is your section 2, in which we have covered these three topics: covalent bond, ionic bond and polarization. Now in this particular topic we are going to study about solubility. So basically, as you have seen in the previous lecture about solubility, but now in this particular lecture we are going to study about the application of solubility. So solubility is directly proportional to the hydration energy or inversely proportional to the lattice energy. While solving the questions of solubility, you need to understand, you need to learn these two cases. Number one case is, if you have given any series and you have to find the order of solubility, you should know about the case 1. That is, if that particular series contains these elements or these atoms, these ions, then only then you will follow this rule. That is, solubility is inversely proportional to lattice energy. If these ions are common, then lattice energy will be dominant. For rest of the ions, hydration enthalpy will be dominant and solubility will follow a relationship with hydration energy. That is, solubility is directly proportional to hydration enthalpy. You can understand these cases, this concept with the following example. That is, you have given a series: lithium fluoride, sodium fluoride, potassium fluoride, rubidium fluoride and cesium fluoride. You need to tell the order of solubility. So basically, first of all, you need to see which ion is common. So basically, as you can see, fluoride ion is common. And if the fluoride anion is common, then you need to put the formula as solubility is inversely proportional to lattice energy. So as you know, in a particular group, as the size increases, lattice energy will decreases. So this is talking about particular group: lithium, sodium, potassium, rubidium and cesium. When you move from top to bottom, size increases, lattice energy decreases, because you know it very well, lattice energy is directly proportional to charge while it is inversely proportional to size. So basically, lattice energy decreases and then solubility increases. Next, there are various examples which help you to understand the concept of solubility. For example, if we take the example number 4, sodium fluoride, sodium chloride, sodium bromide and sodium iodide. As you can see here, we are talking about a particular group, that is a halogen group number 17. Size increases, that's why lattice energy decreases, and when lattice energy decreases, solubility will increases. And we have put the concept of lattice energy here because sodium ion is common. As you can see here, if you have sodium ion common, then you will put the formula as solubility is directly proportional to lattice energy. In this particular case, as you can see, SO4 minus ions are common and SO4 minus anion are not in this particular case. That's why you will put the formula as solubility is directly proportional to hydration enthalpy. And down the group, hydration enthalpy decreases, therefore solubility will also decreases. I hope now you all are cleared about the application of solubility. Now in this particular case, we are talking about bond parameters. There are various bond parameters which will help us to understand about the bond. Number 1 parameter is your bond length. So basically, in molecular geometry, bond length or bond distance is defined as the average distance between nuclei of two bonded atoms in a molecule. It is transferable property of a bond between atoms of fixed types, relatively independent of the rest of the molecules. Or you can say simply the average distance between the nucleus of atom is called bond length. Bond length are measured in the solid phase by means of X-ray diffraction or approximated in the gas phase by microwave spectroscopy. A bond between a given pair of atoms may vary between various molecules. For example, the carbon to hydrogen bond in methane are different from those in methyl chloride. It is, however, possible to make generalizations when the general structure is the same. Now, this bond length depends mainly on electronegativities on the constituent atoms. You need to understand the concept of electronegativity. There comes two cases in particular bond length. When case 1 is when electronegativity difference is 0. In case of homoatomic series or in case of homomolecules. You have given the bond length as Ra and Rb. Ra stands for the bond length of atom A and Rb for the bond length of B, atom B. And the total bond length becomes Ra plus Rb, where Ra is the covalent radius of A, Rb is the covalent radius of B, that is your average distance between two atoms. Xa is the electronegativity of A and Xb is the electronegativity of B. When you have electronegativity difference of 0, then you may conclude that bond length is equals to twice of Ra or twice of Rb, as in case of Cl2 molecule. Now, second case is electronegativity difference is not equals to 0, which means you are talking about heteroatoms. You are talking about heteromolecule. And this electronegativity difference is not equals to 0, then bond length is given by Shoemaker and Stevenson formula, which you have seen in the previous lecture of periodic trends. Now, in that particular case, when bond electronegativity difference is not equals to 0, then to calculate the bond length, you have the formula as Ra plus Rb minus 0.09 into difference of the electronegativity of the two particular atoms. Xa is the electronegativity of A atom and Xb is the electronegativity difference of B atom. Now, the factors that affects the bond length. Number one factor is your electronegativity. Bond length is inversely proportional to the difference of electronegativity, which means if you increases the electronegativity, then the bond length will decreases, as in case of this particular example. Second point is bond order or number of bonds. Bond length will increases if the number of bonds decreases, which means a single bond atom has the minimum bond length, has the maximum bond length, or a triple bonded atom has 3 bonds, has the maximum number of bonds, it has minimum bond length. Now in third case, bond energy is directly proportional to the number of bond. As the number of bond increases, bond energy will increases. In particular, triple bond atoms, in between the two atoms, if triple bond exists, the bond energy will be maximum for this particular case. Now this is an example. As you can see, in between the two atoms of carbon, a single bond is there, in this double bond is there, and in this triple bond is there. When you move from left to right, the number of bonds are increasing. Number of bonds are increasing, that's why the bond length is being decreasing. As you can see here, bond length is inversely proportional to the number of bonds. Here number of bonds are more, 3 bonds are there, that's why bond length is decreasing. Here 2 bonds are present, that's why bond length is this, and here single bond is present, that's why bond length is maximum. Here I would like to tell you that you don't need to remember these or these values, these data are the calculated experimental value. Only what you need to understand is the concept. Only you have to remember the relationship between the particular parameters. Now, if the bond number of bonds are increasing, then bond energy will also increasing. As you can see here, in between two atoms of carbon, single bond is present. That's why bond energy is minimum, that is 80. In between these two atoms, three bonds are present. Triple bond is present. That's why energy is maximum, that is 180 kilocalorie. Now, here in this second example, the heteroatoms have been taken, that is carbon and oxygen. In this case, single bond is present. In this case, double bond is present. And in this case, triple bond is present. As you can see, bond length is being decreasing as the number of bond increases and bond order increases. Next is hybridization. Bond length also depends on the hybridization. Bond length is inversely proportional to the S character. As you know, the alkane has the maximum S character, while moving from alkane to alkene, S character decreases, and to moving from alkene to alkyne, S character decreases very sharply. That's why if S character is being increases, then the bond length will decreases. Next is bond angle. Second parameter is your bond angle. The angle between any two adjacent bond is known as bond angle. This bond angle is represented in degrees, minutes and seconds. Bond angle is directly proportional to the number of bonds. If the number of bonds are maximum, then the bond angle will increases. Second is your hybridization. In particular hybridization, two cases are possible. Case 1, when hybridization is same, bonded atoms are same and central atom and lone pairs are different. In that particular case, bond angle is inversely proportional to the lone pairs. As you can see here in this particular example, bonded atoms are same, that is your hydrogen, but number of lone pairs are different. In CH4 there is 0 lone pair. In NH3 1 lone pair is present. In H2O 4 lone pairs are present. Hybridization is same, that is sp3, and bond angle is decreasing as the lone pairs are increasing. As you have seen here, bond angle will increase if the lone pair will decrease. But in this particular case, lone pair is increasing, that's why bond angle is being decreasing. Case number 2, when hybridization is same, bonded atoms are same, lone pairs is same, but central atom is different. When central atom is different, in that particular case, bond angle will shows a direct relationship with electronegativity of central atom. In this example, as you can see, we have taken a group that is nitrogen, phosphorus and arsenic. Bonded atoms, hydrogen are same in all the cases, while the lone pairs are also same. But as you know, from top to bottom in a particular group, size increases, then electronegativity decreases. And if electronegativity will decreases, then the bond angle will also decreases. Now, case 3rd, when hybridization is same, lone pair are same, central atom is same, but bonded atoms are different. And in that particular example, as you can see, hybridization is same, bonded atoms are different, but the central atoms are same. Then the electronegativity of bonded atoms decreases. If the electronegativity of bonded atom decreases, then the bond angle will increase. As you can see, from top to bottom, electronegativity decreases and the bond angle is being increasing. Also, bond angle is directly proportional to the size of side atom, size of the bonded atoms. Next parameter is your bond energy. Basically, there are two kinds of energy. Bond energy. Number 1 is the formation energy and number 2 is the dissociation energy. Bond formation energy is that energy which is released when any bond is formed, is known as bond formation energy. While bond dissociation energy is the energy required to dissociate any bond, required to break any bond between two atoms, and that particular energy is known as bond dissociation energy. Case 1. In diatomic molecule, or in case 2 for polyatomic molecule, bonded energy is equals to the bond dissociation energy. Now there are number of factors which affects the bond energy. There are 7 major factors, that are electronegativity difference, bond order, atomic size, bond polarity, hybridization, resonance, and lone pair electrons. So now we are going to study about all the factors. Number 1 is your difference in between electronegativity. Bond energy is directly proportional to the difference of electronegativity. For example, as you can see here, HF has the maximum bond energy while HI has the minimum bond energy, because you know it very well, fluorine, chlorine and bromine and iodine, when you move from top to bottom, electronegativity decreases. That's why bond angle is also decreases. Next is bond order. Bond energy is directly proportional to the bond order. As the number of bonds increases, bond energy will increases. For example, as the bonds are increasing in case of triple bond, there are 3 bonds, then the bond energy will be maximum, while in this case where a single bond is present, in that particular case bond energy will be minimum. Third is atomic size. As the size of atom increases, bond energy will decreases, because bond energy shows a relationship with atomic size in as inverse ratio. And the exception of this atomic size is this. Next factor is your bond polarity. Bond energy is directly proportional to the bond polarity. Next is hybridization. Bond energy is directly proportional to the s character in the hybrid orbital. As the s character increases, bond energy will also increases. As you know, sp orbital has the maximum s character, that is your 50% s character and 50% p character. So this has the maximum bond energy, while sp2 orbital has the comparatively minimum s character as compared to sp bond. That's why it has minimum bond energy, and the least bond energy can be seen in the sp3 orbitals. Next point is resonance. Resonance can be defined as the delocalization of pi electrons in a particular ring. This ring could be of any organic compound. It could, for example, in case of benzene. So basically in benzene, bond energy of CC bond is increases due to pi electrons of C double bond C. Bond energy increases due to resonance. And number 7 is lone pair. Bond energy is inversely proportional to the number of lone pairs. If there are maximum number of lone pairs present in a particular molecule, then its bond energy should be minimum. Now I hope you all are cleared about the bond parameters. You have seen bond length, you have seen bond angle, you have seen the bond energy. These 3 factors plays a major role, and from these factors every year a question has been asked in every competitive exam, also in the GATE exam. So you need to learn all the relationships between all the formulas. Now there is a practice question. You need to solve this. The question says, which of the following has shortest bond length? I would recommend you please pause your video here and do it quickly by yourself. I'm giving you some time. Okay guys, so bond length, shortest bond length should be in the F2 ion. And the answer is your 2, that is your F2. Sorry, this is F2. Now the question is, write down the order of bond energy for the following. You have seen this order in the previous slide. Here I would suggest please pause your video and do it quickly. Okay guys, the order should be this. HF should have the highest bond energy while HI should have the minimum bond energy. Now, in case you are new here, you can like, share or subscribe to our channel, that is GurMantra Shiksha Ka Granth. You can also join our Telegram channel for more new updates regarding to your exam. You can also get PDFs and notes. You can also join our Facebook page, that is GurMantra Shiksha Ka Granth. For further queries, please mail us on tanejanehaofficial@gmail.com or you can contact us on the given number. Thank you.